privilege of interviewing many of you, actually, some of you I recognize, the founders and contributors of IoT open source projects leading to the conference here. And here's what I found out. I found out they love acronyms. IoT, M2M needs Mqtt, CoAP, XMPP, AMQP, which works great with TCP UDP. And don't forget the IP RPL to connect via BLE, NFC, 3G, PP. And if you didn't get any of that, just I am my IOE SME. All right, so my talk will cover the following. A brief summary of an industry-wide research that our agency conducted on open source standards and platforms. And specifically, I'm going to business use cases exploring more common business needs and the corresponding IoT open source projects that can meet the market requirements. Specifically, I'm going to address interoperability, scale, smart cities, smart homes, and means to tie disparate pieces together rapidly and efficiently to deliver time to benefit. Remote locations where there is a lack of reliable Wi-Fi or cellular service. Enable utilization-based business models, and finally support high-volume, real-time analytics. And by the way, I'm going to do all this without breathing, so keep up with me. So in terms of the methodology that we employ for our open source project survey and research, it was meant to provide a cross-section of open source projects. And the scope was not to reach 100% comprehensive coverage, but rather to get a diverse representation among open source IoT projects. Now, in terms of our methodology, we employed a combination of a survey questionnaire, a video interview, and secondary sources from websites, reports, and other sources. Now here's a list of some of the open source projects that are in the study. So I'll give you a minute to take a look at that. So for those of you that are interested in the details behind the report, this will become available in early fall. And I will also be co-authoring a chapter on IoT open source in the upcoming John Wiley and Sons academic publication in late 2015. By the way, this presentation will be available for you online. The survey questionnaire that you're seeing here was broken down into the following categories. Now, this is only a partial list with possible answers. By the way, all the bad answers were given to the other study at the other conference. Now, for most of you, you guys are probably familiar with the IoT architecture, so I'm not going to spend a lot of time here. But again, this will be available online. But what I do want to spend a little bit more time is on the tech stack, which is here. So what this slide gives you is a granular view of the technology stack separated by the application data layer, the transport layer, the network layer, the data link MAC layer, and then of course the physical layer. Note that more common protocols and standards are listed on the right. Now I met one of you guys out there that told me that you guys traveled for some 10 hours. And I said, gosh, you must be exhausted. He said, oh, I'll be all right. I'm going to plan to sleep during your session. So welcome. So let's go ahead and get started. For most businesses, at the top of their business priority in regards to building an IoT solution is interoperability. Now these standards and protocols enable systems and devices to find and to communicate across profiles such as mobile, wearables, in-vehicle infotainment, TVs, cameras, printers, and appliances. Standards bodies include All-Seen Alliance with the All-Joint Framework. And just as a disclosure, I am a member of the All-Seen Alliance. The Open Interconnect Consortium, or the OIC, and with their IoTivity, open source software framework. The Industrial Internet Consortium, Oasis IoT, M2M, Eclipse, and others are working on standardization, reference implementations, and certification programs. Now the standards plus the implementation reference helps to ensure interoperability among products, regardless whether we're talking about different manufacturers or across the different verticals. Now, this All-Scene Alliance Consortium has some 120 members and we're quickly growing. We have companies such as Qualcomm, Microsoft, Panasonic, Sharp, and others. And All-Scene Alliance is really dedicated to enabling and driving the widespread adoption of products, systems, and services that support the Internet of Everything, with an open, universal development framework supported by a vibrant ecosystem and a thriving technical community. Now, it is by far the broadest cross-industry consortium to date that's going to advance adoption and the innovation in the Internet of Things in homes, industries, and other verticals. OIC, or Open Interconnect Consortium. OIC was founded in July 2014 and has 50 or more members at this point, including Intel, Samsung, Cisco, Acer, and Dell. Now, one of the things that's really interesting is that IoTivity, which is the all-join comparable for OIC, is similar in terms of the capability and the framework of all-join, but it really allows for flexibility for your vertical or for your firm. So if you're looking for something flexible, I highly recommend taking a look at IoTivity. Now, its salient capability is in the abstraction transport layer. Eclipse Foundation. This grew out of the IBM Eclipse project and has over 228 members, including IBM, Google, Oracle, SAP, Siemens, and BMW. Another market requirement that illustrates the need for scale is this chart. Firms are really looking for platforms that can support large-scale implementations. And I know that's why all of you here are, because you want to see what type of system is going to be robust enough to be able to provide that scalability. But what are some available options for us in terms of solutions, open source solutions to consider? Well, before we can get into siteware and webinars, we need to first understand a few protocols and standards. The more popular ones: Mqtt, XMPP, CoAP, AMQP, and I'll cover CoAP in a later section of the presentation. MQTT is a message queue telemetry transport, which is a lightweight publish-subscribe messaging protocol designed for resource-constrained IoT devices and low bandwidth, high latency, or unreliable networks. And it's really ideal for remote locations where you need a small code footprint, or maybe the network bandwidth is at a premium. XMPP, it's the Extensible Messaging Presence Protocol. It's a communication protocol for message-oriented middleware based on XML. It was originally called Jabber and has been extended to use in a publish-subscribe and IoT applications such as for smart grid. AMQP, Advanced Message Queuing Protocol, is an open source application layer protocol for the message-oriented middleware. And its key features are message orientation, queuing, routing, including point-to-point, publish and subscribe, reliability, and security. All right, so let's get into siteware. Siteware allows businesses to create IoT solutions without custom coding. Wow, that's exciting. Devices can be assigned to physical or logical assets via pluggable commercial off-the-shelf modules. And it also supports numerous IoT protocols such as MQTT, JSON, AMQP, XMPP, STOM, JMS, WebSockets, while also providing published APIs. Now, event data can be stored in the cloud or on local servers. And the solution is fault tolerant, scalable, and cost efficient. And communications with devices is bidirectional and asynchronous. allowing software to manage solutions that require very large numbers of devices and event cycles. The software also provides interfaces for customized event triggering, searching, and analytics, as well as out-of-the-box support for rapidly integrating customized device data into other platforms. By the way, Xively, that was recently acquired by LogMeIn, is probably most familiar or similar to Siteware, which is also based on Mqtt. Siteware claims that their solution is faster to deploy in Xively, with the advantage of deploying into the cloud as well as a local server. Webinos. Webinos has some 30 project partners across Europe, and its platform consists of an application platform, connected everything protocol, and security framework. It's promoted as a single service for every device, and it supports the deployment across a wide range of connected devices. And the gateway consists of complete end-to-end specifications of reference hardware for platform and example applications. And standards and protocols include HTTPS, JSON, RFP. Now some of you are probably asking, what is the holy grail of smart cities? Well, it's simple. We'll finally be able to measure how polluted and congested our cities are. Now, that's a joke, by the way. When we talk about scale and scale and fragmentation, there's nothing that poses a greater challenge than smart cities with just a heterogeneous, diverse nature of it, right? And so for those of you looking for a smart city open source toolkit, what are some of the options that you need to consider? Well, before we dive into Riot, Contiki, and others, here's one more protocol that you need to be familiar with, which is CoAP. CoAP stands for Constrained Application Protocol. It's an application layer protocol that is intended to use in resource-constrained internet devices, such as wireless sensor nodes, low-power sensors, switches, valves, and components controlled and monitored remotely through the internet networks. Again, the key is resource-constrained. At the OS layer, we have two projects, Riot and Contiki. Riot is an open source microkernel operating system that is an alternative to Linux OS. And both Riot and Contiki focus on sensors with very minimal processing and memory, but allows for full OS capability on a tiny sensor device that would typically not support a Linux or an Android, for example, because of the lack of power or memory or processing. It supports multiple chip architecture, including MSP430, ARM7, Cortex-M0, M3, M4, and so forth. Both Riot and Contiki use Ripple, which is an exciting mesh networking protocol if you're not familiar with it. Specific to Contiki, it supports standards like the IPv6, 6LoWPAN, Ripple, CoAP, TCP, HTTP, Mqtt, DNS, JSON, and others. By the way, for those of you that are just joining, you missed the joke on the acronyms. It's highly efficient memory allocation, full IP networking, very low power consumption, and dynamic module loading. All right, let's move on to middleware. Open Remote, which is a middleware solution that's focused on home automation, commercial buildings, public spaces, and other verticals. It's meant to be protocol agnostic and operates with off-the-shelf hardware. And its architecture enables fully autonomous and user-independent intelligent buildings. End-user control interfaces are available for iOS and Android and web-based interfaces. And user interface design, installation management, and configuration can be handled remotely with open remote cloud-based design tools. Now, in terms of a case study, when I spoke with Open Remote founder, one of the things that they did, which was exciting, was an actual implementation with the city of Eindhoven. What they did was they used Open Remote to be able to build a crowd management system with workflow and messaging, data data visualization software was integrated with devices, sensors, and subsystems via a local controller or hub. And using street sensors and the system was able to count the number of people walking by on the street, or measure the city sound levels, for instance, and use lighting as actuators. And there's also a UI dashboard that they created, which is available on mobile devices to view crowd management metrics. I was just at IBM Amplify yesterday, and I had a chance to speak with Reddick, who is the founder of Works, which is a competitor to Nest, iControl, and PeoplePower. So we know that there's a lot of activity and competition that's brewing within the smart homes category. So for those of you that are interested in entering this category, what are some open source projects that's going to give you a head start? Well, OpenHab offers a framework based on the OSGI, or the Open Services Gateway Initiative. And OpenHab has a modular architecture that allows contributors to be able to add devices, including legacy protocol based on devices and standards and component support. And it's really ideal for connected home because you have things that are like water heaters that are super old and that's based in some 1950s spec. So it really allows for you to be able to create a single solution that provides an overarching automation rules as well as a uniform user interfaces, because what you don't want to have are dozens and dozens of user interfaces to control all your devices, right? Now for enterprise use, OpenHab Core Framework can be used within the Eclipse Smart Home project. So the fact that they're tightly integrated means that any changes to the OpenHab code source gets shared seamlessly with the Eclipse Smart Home project. Now what the Eclipse Home project does is it tries to address some of the fragmentation in terms of the smart home ecosystem with a common set of interfaces and APIs to integrate the connectivity, the automation, as well as the user interface and then the persistence aspect of it. HGI, or the Home Gateway Initiative.
Ladies and gentlemen, please note that the Internet of Things World Speed Networking session is about to commence. If you are participating, please make your way to the back of the Internet of Things exhibition immediately. Thank you.
And I am participating. HGI is a consortium of major broadband service providers like the Deutsche Telekom, Telecom Italia, and Mqtt, as well as home consumer electronics manufacturers that builds smart home ecosystem. Now, what HGI does is they publish requirements and test plans for home gateways and wireless home networks with the goal of enabling applications and home gateway middleware and the network-based set of devices to be able to connect seamlessly. It's actually much harder than you think if you actually haven't looked into this. Love this slide because what it shows is that it illustrates how piecing all these different components and services is a massive headache. It's a nightmare. Yet your stakeholders are asking you, saying, how do we actually deliver a product to market or time to benefit if it's for internal use? Well, how do we do this? On the API side, you have Zeta, which is built on Node.js and helps link IoT devices with the cloud to create a geo-distributed networks. And Zeta combines REST APIs, WebSockets, and reactive programming, which is really ideal for assembling devices that is data intensive and that requires real-time applications. By the way, Zeta also powers commercial products like the Epigee. So we know that this is working. OpenIoT, and I believe the next speaker is going to be speaking on this very topic. Middleware, excellent tool for pulling all that information from sensor clouds without having to worry about what sensors you need to use. And it explores efficient ways to use and manage cloud environments for IoT entities and resources such as sensors and actuators and smart devices, and offers a cloud-based, utility-based sensing as a service, a SaaS type of model with an adaptive firmware framework for deploying and providing services in a cloud environment. Now, they have developed use cases for a number of verticals, including smart agriculture, intelligent manufacturing, urban cloud sensing, smart living, and smart campuses. Now, depending on the IoT solution that you're building, there's probably a use case where Wi-Fi or cellular coverage may be potentially limited. So what do you do then? Well, whether we're talking about live events, remote areas, or managing agricultural land, mesh networks offer connectivity when there's limited Wi-Fi or cellular service. And interestingly enough, even though I live in Silicon Valley, it gets very spotty, so this applies for smart cities as well. Open Garden. Open Garden IoT SDK enables IoT devices to connect to the internet and to communicate with other nearby devices using a peer-to-peer mesh networking connectivity to share and to receive data faster and more efficiently, automatically and actively switching between the best available networks without the users involved. Now, what's really interesting is that they claim that they have some 5 million people that are using Open Garden. If you've never heard of Open Garden, they're also the ones that are making fire chats. Very bullish in this space. Now, some startups are using Open Garden and low power wide area network, or LPWA, to create off-the-grid wireless messaging network, with claims that it can work up to 20 miles radius, supporting up to 50 kilobits per second over 50 channels. So if you're from a telecom, you should be worried. I would be. OpenWS, OpenWSN, or Ripple. So OpenWSN supports Ripple, RPL, which is a routing protocol designed for low power and wireless sensing networks. And it operates on top of 802.15.4e. And its routing layer is responsible for relaying packets across multiple hops, separating source and destination nodes, and it's divided into a follower engine, which uses a routing table to decide which neighbor node is the next hop for that packet, and the routing protocol, which populates that routing table. Now, another market requirement that we hear often is, how do we monetize off IoT based on a utility model? Well, if your company needs the ability to be able to charge accordingly, not just by day, per week, or lease, but by the usage pattern, whether it's by RPM, acceleration, or the number of the time that the front loader was raised. By the way, to be very serious, we believe this is going to curb tractor racing and donuts. Now, Chimera IoT is building platforms that allows enterprises to be able to build real-time mobile and web applications with usage-based monetization and reconciliation visible by the billing company as well as the users. Its messaging service, which is the underlying component, is RabbitMQ. If you haven't heard of it, you need to look into it. It is an open source project that's utilizing AMQP messaging, and it supports robust messaging for applications. Runs on all major OS, and supports a large number of development platforms. Now, Chimera IoT is unveiling a portion of their platform, including their server design for messaging system and the device drivers for Android and Texas Simple Link Bluetooth Smart Sensor Tag. Going a little bit fast because I know that your attention span is short, and so is mine. All right, high volume transaction in itself is a big challenge. We know that, right? Big data. But what about those companies that are looking to implement real-time analytics? You need to know it now, or your consumers need to know that information. So how do we tackle that challenge? In-memory data grid, which primarily relies on main memory for computer data storage to access data in memory. Now, the two following projects that you're seeing here support enterprise-grade memory computing solutions for high-volume transactions, real-time analytics, and hybrid data processing. Mqtt, bless you, is an open-source, standards-based cache for boosting performance, offloading database, and simplifying scalability. And it is the most widely used Java-based cache. And that cache scales from in-process with one or more nodes all the way to mixed in-process and out-of-process configuration with terabyte size cache. Hazelcast. Hazelcast provides in-memory NoSQL, Java caching, data grid, messaging application, scaling, and clustering. Again, very briefly, but please take a look at these. Very serious. Now, I had to rush through it because my next speaker is getting ready. For those of you that are just waking up, I'm very pleased to tell you that I'm only on slide 2. I'm just kidding. So, we all know what the appeal of open source is, right? I mean, it's right here. Scale, velocity, low cost, it's all there. And matter of fact, today's most competitive proprietary IoT open source platforms and solutions, and I've actually looked at every one of them, or my colleagues have, and I can tell you that a lot of them are actually, to a great extent, using these open source technologies under the hood. That's their secret recipe. That's their ingredient. Okay? So here's a message. Just because you're the IBM, Intel, and the Cisco of the world, and you're a blue chip publicly traded company, doesn't mean that you have infinite resources at your disposal. Matter of fact, your sponsors are wanting quick solutions that demonstrate benefits before they're willing to commit to a full-fledged IT project. Am I right? And for those of you that are from the startup arena, you need to get up and running fast. But you don't have legions of developers. You have 2-3 people sitting in your living room. So what do? Well, in both scenarios, open source enables you to do more with less. The message is simple. Don't do from scratch. Leveraging these incredible open source projects accelerates your product development. And in the process, you become the hero, right? You become the innovative leader within your organization.